Hello everybody. In this video we are going to look and see how we can use our dashboard to do two-sample hypothesis testing for means. Let me just clear this up real quick from an old example that I was working on, and then we will go ahead and get started. So let's go ahead and read our scenario. So it says that Dallin has two friends who have each decided to start up a new moped company. Trying to be eco-friendly, they independently invested in hydrogen fuel cells for their power source. Each of their designs are slightly different, and because of this, Dallin suspects that on average, Go Bikes has a different kilometers per liter performance than that of Hydrogen Scoot. He wishes to test at the significance level of 6%. So he randomly selected mopeds from each of their production lines, put a liter of hydrogen in each of them, and drove them until they quit. Here's the data that he collected. So first things first, we're going to grab our data, and I'm just going to go ahead and copy this. Give me a second. Oh, maybe not. There we go. Copy. And I'm just going to do a right click, paste special as text, and OK. So the nice thing about this is it drops it into this orange section. Now, if you forget, there's a little bit of instruction over here. You can do this from just summary data if we know the summary statistics like the sample mean and the sample standard deviation of each group. But we can also do this by just pasting the raw data into the orange cells, the grouping variable in column B. We fill in the yellow cells, and then we copy the pertinent descriptive statistics into the green cells. Okay, so let's get, before we go any further, we have copied in our data, and now we can start to go on. So the first thing is, what type of data that are we dealing with? So we're dealing with numerical data because we are looking at the kilometers per liter. And the grouping variable of interest is this moped company, is the company that we are dealing with. The response variable of interest is the kilometers per liter. It's also known as like our dependent variable, but this is what we are trying to look at. If we look at the populations of interest, it's going to be this hydrogen mopeds from both the Go Bikes and the Hydrogen Scoot. And then the parameter of interest is the true mean kilometers per liter for each of the mopeds. Okay, so which method should we be using for our test statistic? And it says that we should be looking at this two independent t-tests for difference of means using unequal variances. Now you might be like, how do we know that it's unequal variances? We're going to come back to this in just a second, but our appropriate test statistic is going to be our t-statistic, and do we have a large enough sample size? And we need to know, we'll come back to this one too, because we have to have, by the central limit theorem, since nothing in there said that it was normally distributed, we have to have at least a sample size of 30 for each. So the first thing here that I want you to know, it says that group 1 is going to be Go Bikes and group 2 is going to be Hydrogen Scoot. So here we go. Let's say group 1 is equal to Go Bikes. I'm just going to go ahead and click on it over here to Go Bikes so that it's typed in perfectly. And then Hydrogen Scoot is going to be group 2. And I click OK. So notice over here, it then has our descriptive statistics for Go Bikes and Hydrogen Scoot. Notice how the sample sizes are both over, or at least 30. So we can say that, yes, the sample size is at least 30 for both samples. And how do we know that it's going to be equal or unequal variances? Let me go ahead and grab our flowchart real quick. And let's kind of go look at our two-sample hypothesis testing real quick. So if we scroll back up to the top, first things that we're asking is like, okay, what do we want to know? We know that it's numerical, so we're looking at a difference in two means. We already looked at our population and our parameters, and these are some good ways to help us identify these ones. And we want to be able to state our null and our alternative hypotheses. So because we're dealing with means, we can kind of focus in here that our null hypothesis is going to be the true mean of group 1 minus the true mean of group 2. Is going to be, and we're going to use just this equal sign. That's typically what we use, is our equal sign is equal to 0. And the alternative hypothesis from our scenario, we have to determine if it's going to be less than, greater than, or not equal to 0. Okay, so let's come back here. We can set up our null hypothesis as a 0 right there. And we need to go back up and read our scenario, and it says each of their designs are slightly different, and because of this, Dallin suspects that on average Go Bikes has a different kilometers per liter. So different is our keyword. If we're just saying different, that isn't giving us direction, so we're going to use not equals. And to type not equals in Excel, it's that exclamation point and equal sign. And the alpha here we know is 6%. So we're going to do 0.06 for our alpha. And then we can copy here our summary statistics that was calculated for us. You didn't have to do any of these calculations. It calculates that for you. We want to copy it. And then down here, we're going to paste special in the green cells as just values, and it calculates everything else for you, which is great. Okay, so we have all of that, and now we need to know, how do I know if this is going to be equal variances or unequal variances? Let's go back to our flowchart, because our flowchart helps out a lot. Let's grab it here. Okay, so we got a not equal. So mu1, or we have a true mean of group 1, true mean of group 2. We got our inequalities from the scenario. Let's go down here. In step 4, we established our alpha, that is 5%. And then the testing method here is we are doing 2 sample testing. We know that it's means. Is it matched pairs? And it's not matched pairs. Remember, matched pairs, it has to be like a one-to-one link between each of the groups being measured. So it would be like, a twin study or like a pre and a post measurement. Those are things that are like matched pairs. And so we have to know here, it's like, are the variances equal? And we have to do a Levene's test. If we come over here, we can actually see how do we do a Levene's test. And a Levene's test is just a baby hypothesis test that says, okay, these 2 samples, if they have equal variances, that's the null hypothesis. And the alternative hypothesis is that the 2 samples have unequal variances. So we're going to do a calculation, and basically we're just looking for a p-value here. If the p-value is less than alpha, we reject. If the p-value is greater than or equal to alpha, we fail to reject. And when we reject, we say we use unequal variances. And if we fail to reject, we use equal variances. So that's like the best way to do it. Let's go look at this Levene's test. So the Levene's test here is this variance check. We have Levene's. Remember, the null hypothesis is that they're equal. The alternative is if they are unequal. The p-value is really the only thing that we need to know. And this p-value is basically 0, so it's less than our alpha value here. So we're going to reject the baseline claim that we have equal variances, and that's why we're going to be using the unequal variance line. So we have all of this information for the unequal variance, and it's because this p-value is less than alpha that we decide that we should use the unequal variances. Okay, so scrolling on down, there's another way that I also teach in my in the videos and notes. You can also do a standard deviation ratio, which is just dividing the biggest standard deviation by the smallest standard deviation. And as long as this standard deviation, like rule of thumb, is below 2, you use equal variances. Anything above 2 is unequal variances. A lot of times these have similar results. The Levene's test is the better way to do it, but we also do talk about the standard deviation ratio. And so here, it's also, this is way over 2, and so we would have unequal variances from there as well. So that's how we know that this is going to be a 2 independent t-test for a difference in means with unequal variances. Okay, we already set up our null hypothesis. We already set up the, the alternative hypothesis. There we go. Oh, there it is. Yep, the alternative hypothesis. Scroll on down. Okay, we have our alpha level. Okay, if we want the mean of group 1, I mean, it's literally the x bar here is 25. The x bar of the second one is 35. The test statistic, this t statistic right here, is negative 1.305. Determine the p-value. If we look at our p-value, it's going to be 0.1981. There we go. The p-value is going to be greater than alpha. It's bigger than our 6%. And our confidence interval, check this out. It calculates it for us. So we have a 2-tailed confidence interval with an upper and a lower. So we have from 24 to 46. We say that this is going to be a failed to reject the null hypothesis. And so we would say that Dylan has collected insufficient data. So we have t with this degrees of freedom, which is calculated right here, with the test statistic and the p-value on our alpha to reject the claim that the true mean of kilometers per liter of Go Bikes and hydrogen scoot are the same. So we have insufficient evidence to say that they are not the same. Okay, so there's our conclusion, and that's it. That's how you do all of the steps of this hypothesis testing for means using this dashboard. This dashboard is really nice. The only thing that you really need to remember is you have to fill in all of the yellow sections. You have to paste in your data correctly. Remember, the grouping variable is in column B, and what we're interested in is in column C. Once we have told it what our 2 groups are, we're going to copy our data paste it into the green cells, it'll fill those in. And then the last thing that you need to do is do your variance check. If the p-value is very small or smaller than the alpha, we're going to use unequal variances. If the p-value is bigger than alpha, we'll use equal variances. Alternatively, there's the standard deviation ratio, which is just dividing the largest standard deviation by the smallest standard deviation. As long as it's smaller than 2, you're going to be using equal variances. Over 2 is typically going to be using your unequal variances. But the better one to do is this Levene's test. Standard deviation ratio is just kind of like a rule of thumb. Okay, there you go. That's how you do two-sample hypothesis testing using the dashboard. Good luck, you guys.